Welcome to Sundar's lecture. This is lecture number 69, and in this lecture we are going to see transient responses of LC circuit, right? We have taken with an example, we have not gone with the default LNCs because with example you can easily understand the concepts behind LNC circuit. See, we are not taking it, we have not considered R here, so it is not RLC circuit, it is just LC, only inductor and capacitor. See, we have connected LNC like this in this manner, and we have put a switch over here, and before closing the switch we have to assume that the capacitor carries 10 volt and there is no initial current flown through the inductor. These two conditions you have to assume it before closing the switch, right? Now after, if S is closed, let us we assume that if S closed, then what happens, the circuit will be now fully closed. And now if you want to write the KVL expression, what you will get, see, by KVL, I am just going to write the expression by KVL. What you will get, see, from here the current is flowing in this direction, so in capacitor it will travel from minus to plus. So now if I want to write the expression, so in the this will be now plus, this will be minus, so my current will travel from minus to plus, so it will be plus V of t, and from plus to minus it is traveling in the inductor, so it will be minus L into di of t divided by dt, and that should be is equal to 0. So this is the expression for using KVL. So I make this expression as number 1. See, if I want to write what is the value of I of t, so what is the I of t? The current flowing in the capacitor. So see, if current flowing from plus to minus in the capacitor, then we will assume that as plus C dV by dt. But now this current is flowing from minus to plus, so it will be now minus C dV by dt. Now this is expression number 2, which means this is V of t. You have to assume, right? I have already told you. Now what you do, put 2 in 1, what you will get? So if I substitute, so I will put now V minus L d by dt is already there, and instead of I of t I need to substitute these values, so minus C dV by dt, that should be is equal to 0. And if you further simplify this, what you will get, this will be V plus LC, then it will be now d square V by dt square, right? That should be is equal to 0. And now you see, I need to get, this is second order differential equation with no exciting function. Then if you divide this by LC, divide this by LC in both sides, divide LC in both sides. So what you will get, finally I will get d square V by dt square plus V by LC, and it will be V, sorry, V by LC, and that should be is equal to 0. Now make it as expression number 3, and we know the values, right? What is the values now? We know what is the value of L and C, everything we know, right? So what is L here? It is 2 Henry. What is C here? It is 2 Farad. Now you substitute here, so it will be d square V by dt square, and then plus V divided by, if you multiply these two, what you will get? 2 into 2, it will be 4, and that should be is equal to 0. And now this is the expression. Now this is the expression, and I have just substituted L and C. L is equal to 2 Henry and C is equal to 2 Farad. I have just substituted these two values here in this expressions to get this one. So now, I have to solve this differential equation. This is second order differential equation. So if you want to find what is the characteristics equation, so it will be d square plus 1 by 4, and that should be is equal to 0. And if you simplify this, you will get two characteristics equation. One will be M1 will be is equal to J, what I am getting here, so it will be J 1 by 2, and the second one will be M2 will be is equal to minus J 1 by 2. This is the value. Now you see, because here you will get complex conjugate numbers, because there is no way to split this 1 by 4 into two terms so that we are getting this one. These kind of things we can easily understand. So here m1 and m2 are not equal. You just take it in that way. We have seen these kind of things already, how to solve differential equation. If m1 and m2 are equal, then we have to write one thing. If m1 and m2 are not equal, then you have to go for the other things. And this is m1 and m2 are not equal, both are not equal. So what is the v of t now? So we can write v of t, that should be is equal to a e power minus m1t plus, maybe here I have written with my plus, right? So you will just write it like this. So b e power m2t and then plus k1x and then k2x dot, it will be going on. So if I substitute in this expression, what I will get for v of t? So v of t will be is equal to a e power j t by 2. I have just substituted, instead of m1 I have just substituted this value, and then plus b e power m2, that is nothing but it is minus j t by 2. See what happens to k1 into x. What is x here? X is the 0. There is no excitation function, so everything will become 0. So k1 into, you don't need to put anything here. So this is the final expression for v of t. And we know what is the initial condition of v of t. So v of 0 will be 10, right? So you just substitute that one. So v of 0, we know that it is 10, and if you substitute in this expression t is equal to 0, it becomes 1, so it will be a plus b. So finally I can write a plus b, that should be is equal to 10, make it as expression number 6. And then what you need to do, you need to find what is the I of t value. It is very simple, right? We know what is I of t. It is simple to write. I of t can be written as minus c dv by dt, and we know that I of 0 value, it is 0. We know that, right? We have already taken in the initial conditions. So it will be 0. So a minus value, what is c value? It is 2. So it will be now dv by dt. And you see this 2 can come to this side, and it will be now dv by dt will be is equal to 0. And we know what is v, right? We can substitute in this expression, right? So I will take it to the next page. So now you see I have taken to the next page, I have taken. So now we have to differentiate this expression, right? I will get d by dt of this value a e power j t by 2 plus b e power minus j t by 2, and that should be is equal to 0. And if I differentiate this one, what I will get it by j by 2, that is the thing, then e power j t by 2, and then plus, here you see if maybe I will not get plus, it will be minus j by 2 b e power minus j t by 2, and that should be is equal to 0. And we know that I of 0 value, we know that, right? Because if you substitute t is equal to 0 in this expression, and that should be is equal to 0, that is what we have seen in the, see here, it will be 0, right? So I of 0 will be 0, then I need to substitute the values of t as 0 here. So if I substitute t as 0, what I will get, it will be j by 2 a, if this becomes 1, and because everything, if it is 0, then everything becomes 1. So minus j by 2 b, and that should be is equal to 0. If you take commonly j by 2 outside, it will be a minus b into j by 2 is equal to 0, and j by 2 will become 0, right? So the next expression will be a minus b, that should be is equal to 0. See, I will make this expression number as 7. See, this is 7, and what is 6 now? A plus b, which is equal to 10, and that is the expression number 6. And if you simplify these two, what is a minus b? This is two unknowns, right? Two unknowns. So if you simplify this, you will get a is equal to 5 and b is equal to 5. This is the values. And now we have found what is a and what is b. Now we can substitute in this expression, right? This is the expression of v of t. It is very easy to substitute in this expression now. So if I substitute, what I will get, so V of t will be is equal to 5 e power j t by 2 plus 5 e power minus j t by 2, right? So if I commonly take t by 2 outside, what I will get, so V of t will be, sorry, not 5 commonly outside, then it will be e power j t by 2 plus 5, sorry, e power, not 5, it will be e power minus j t by 2. So this is the final expression, and we know that we have seen these kind of things, right? Basic trigonometry. If e power j theta plus e power minus j theta will be is equal to 2 cos theta, right? We have seen these kind of things, basic things. And you see this one, instead of theta we have t by 2, right? So what I can write? So v of t can be written as 5 into 2 cos of t by 2. This is the value, and if I substitute everything, if I simplify this, what I will get, so v of t will be is equal to 10 cos t by 2. This is the value, right? This is the value of v of t, and I can make this expression number 8. And we know that I will be here, it is minus c dv by dt. We have seen already this one, right? So I of t can be written as minus 2 into d by dt of this value 10 cos t by 2, right? This is the expression we can write like this. And if I differentiate this one, what I will get, so differentiating cos t by 2, it will be minus sign, right? So it becomes plus 2 sin t by 2 into, and I need to differentiate it again, cos, so t by 2, it will be 1 by 2, right? It t, if I differentiate t, it will be same thing, and 1 by 2, this 2 and this 2 will be, maybe I missed anything, yes, 10 I have missed, right? So into 10 I have missed out, so it will be into 10, and this one, it will be 1 t by 2, this 2 and this 2 will be cancelled out, and finally what I can write, so I of t expression can be written as 10 sin t by 2, right? So this is the I of 2 expression, I of t expression, and I make this expression as number 9. And you see one thing, what is the value of omega, and we have seen these kind of things under AC. Omega will be is equal to 2 pi f, and I can write this as now 1 by t, right? So omega can be written as 2 pi by t, and the t can be written as 2 pi by omega. And what is omega here? See, in both cases, in V of t, this 10 cos omega t, what is omega t here? So in both cases, omega t value will be 1 by 2, right? So omega t, if you put omega t in this expression, instead of omega, you will get 1 by 2, and also here also you are getting omega as 1 by 2, right? In both cases, omega will be 1 by 2, and if you substitute this one to t, which is equal to 2 pi divided by 1 by 2, and if you finally simplify this, you will get t will be is equal to 4 pi, and this is the time period. This is the total time period for single cycle. For one cycle, it takes 4 pi period. And with this basics, I am going to draw the graph now. It is very simple, very interesting to understand. I have already derived the expression for V of t and I of t, but if I draw the graph, you will get a good clarity what happens to LC circuit. See here, nothing will become zero. That is the thing you have to understand. No things will become zero here, and forever it will have some energy stored inside the circuit, and we call the circuit as tank circuit. This will be used in the oscillators. It can be applied in the oscillators, and so many things are the applications of LC circuit. But I am not going very deep into the LC circuit. But I need to show you how the graph will be for LC circuit. So we will take it to the new page. Right now you see I have just taken the graph here, and in this graph we are going to plot what is V of t and what is I of t. See, V of t is 10 cos t by 2 and I of t is 10 sin t by 2. We know these two expressions, and now you see if I put t is equal to 0, pi, 2 pi, 3 pi, and then what is the values I am getting here? I am just going to plot it out here. So what is this values? So at t is equal to 0, it will be 10 volt. So at t is equal to 0, V is 10 volt, V is 10 volt, and at pi it is 0, at pi it becomes 0, and at 2 pi it becomes minus 10. So at 2 pi it becomes minus 10, it will come here, and at 3 pi it again becomes 0, so it will be here, and at 4 pi it again becomes 10, so it will come here, right? So this point will be here, and if I connect these all points, I will get, so these two will be connected, and again these 2 points, and these 2 points, and again these 2 points, right? So now this is the graph, right? So this curve will repeat. This curve will repeat. See, I have drawn for a single time period, one cycle. This is actually one cycle period. This is 4 pi. I have just drawn. And if I want to draw for the current axis, for the current expression, at t is equal to 0, the value will be 0, and at pi it will be 10, and then at 2 pi it is again becomes 0, and at 3 pi it becomes minus 10, it becomes minus 10, and at 4 pi again it becomes 0. That's all. Now if I want to connect these 2 points, these all points, sorry, not 2 points, so it will be sine, right? It will be sinusoidal waveform, so it will come here. So these two are the current and the voltage graph for LC circuit. And I want to tell you one thing. What is the energy stored in the circuit? That is what I need to find it out, right? See, this one, it is very important to understand why I am saying this. See, what is the energy stored at t is equal to pi? At t is equal to pi, maybe at t is equal to pi, what is the value of voltage? Voltage is 0, and at pi the value of current, it is nothing but 10 amperes, right? So so if I want to find what is the energy stored, so energy stored expression will be half CV square, or if it is by inductor, I can write it as half Li square, right? So if I substitute in this expression V, it is 0, so energy stored can be written as half L. What is the value of L? It is 2 Henry into what is the value of I? It is 10. So 10 square, it is 100. So this two will be cancelled out, and finally energy stored, which is nothing but it is 100 joules. This is at time is equal to pi. Maybe you go for t is equal to 2 pi. You just try to find it out. What happens in the 2 pi? So what is the value of voltage? What is the value of voltage here? It is minus 10. And what is the value of current? Current becomes 0 here, right? At 2 pi. So now if you substitute here, so it will be half CV square. So what is the value now? So half into capacitor value, it is 2, into what is the value of voltage? It is minus 10. So minus 10, it will be squared, and then it will be 100, right? So again, again energy which is equal to 100 joules. So what is the point you need to get here? At whatever the instant you take, energy stored will be 100 joules. And what is the initial energy stored? Initial energy stored, I will write it down here. Initial energy stored, which means before closing the switch. What is the initial value of capacitor value? Capacitor voltage value, it is energy which is equal to half C V naught square. I am just writing it as V naught square. V naught, which is nothing but initial voltage, right, voltage of the capacitor. And if you simplify this, you will get again 100 joules. So initially you got 100 joules in the capacitor, and that 100 joules is now stored in the circuit. That is why these kind of circuits are called as tank circuits. The value will be oscillating like this. Maybe in the graph we can see that the current will now oscillate, and how much of energy is stored? The energy stored will be 100 joules at whatever the instant you take. So this is the nature of LC circuit, and this LC circuit will be applied in the oscillators. So you try to understand all these kind of concepts, and we will take another examples in the next class. Thank you.